Welcome, I'm Ann Kellen. NASA's NEAR spacecraft had scientists cheering this past week. It outperformed expectations on its encounter with an asteroid. NEAR was expected to crash onto the surface of the asteroid Eros last Monday. Instead, it landed gently and kept transmitting data. NASA extended its mission by 10 days to give scientists more time to examine Eros. Miles O'Brien has the story.
It was a near hit for the scientists who devised the mission. The little spacecraft that could and didn't disappoint. It came in for a soft landing, beaming back 100 unprecedented close-ups of an asteroid, and then once on the rocky surface, it phoned home.
I'm happy to report that the NEAR spacecraft has touched down on the surface of Eros.
They were surprised because NEAR Shoemaker wasn't supposed to survive the impact. It was at the end of a successful year orbiting the asteroid Eros, creating a photo album 10 times thicker than expected. The team decided late in the game to send it down for a closer look, fully expecting it would be a kamikaze dive.
It was not designed to land. No, I can't believe that we did this. I'm still not believing it. Maybe I'm dreaming all this.
It's a big win for NASA's so-called faster, better, cheaper space exploration policy. The mission cost $223 million, relatively small for a space foray. NASA's administrator, called on the carpet after the loss of a pair of Mars missions a year ago, relished the moment.
How much surprise is there that it's still ticking, so to speak?
1 in 100 was what I was told. Sometimes the gods are with you.
For Science and Technology Week, I'm Miles O'Brien.
The International Space Station Alpha is one step closer to beginning its scientific mission. The station's laboratory module called Destiny is now in place, seen here from the camera on the robotic arm of the Shuttle Atlantis. The mission to Alpha this past week featured 3 spacewalks in which astronauts hooked up Destiny and added a docking port for future shuttle arrivals. The $1.4 billion Destiny won't be fully operational for a few years. Its 13 science stations were too heavy to bring all at once, so they'll be coming on future shuttle missions. Alpha is supposed to be complete by 2006.
Atlantis Rückkehr vorbereitet. Die Raumfähre mit ihrer 5-köpfigen Besatzung soll heute gegen 19 Uhr mitteleuropäischer Zeit in Cape Canaveral landen. Die Wetterbedingungen hierfür sind nach Angaben der NASA günstig. Das Shuttle hatte das 1,4 Milliarden $ teure Forschungslabor Destiny zur internationalen Raumstation ISS gebracht.
We focus our attention on Cape Canaveral, and we have some video to share with you conditions at the moment when they intended to do the landing of Atlantis. The wind was quite high. So in the forecast now, we are not going to deal with high winds because they started to subside. But let me show you on the map also that we have a ridge of high pressure. But this high pressure is pumping air from the ocean here. So we're going to deal now with clouds. So maybe cloud cover is going to be too intense for the landing. So that's the next thing that we have to see. Elsewhere, we have high pressure, chilly mornings in the south, no change. Also in the northeast, quite stable. Here in the mid-Atlantic states and into the Great Lakes, it's going to be stable again. But we are dealing with more rain into the west and also into parts of Canada. We're going to see some snow showers.
Aus der Luft versuchen die Feuerwehrmannschaften, die gewaltigen Brandherde zu löschen. Die Flammen haben sich bereits über Tausende von Hektar ausgebreitet. Ein 16 Kilometer langer Straßenabschnitt in Zentralflorida musste bereits abgesperrt werden. Die Bewohner der Umgebung haben ihre Häuser verlassen. Auch die Hauptverkehrsstraße zwischen Orlando und Tampa ist jetzt durch die Flammen bedroht. Die anhaltenden Brände sorgen in weiten Gebieten Floridas für heftige Rauchentwicklung, schlechte Sicht und Sauerstoffmangel. Im Gefängnis von Polk County wurden 120 Insassen wegen akuter Atemprobleme in eine andere Haftanstalt verlegt. Erst rund ein Fünftel der Feuerherde konnte durch Gräben, feuerabweisende Chemikalien und Löscharbeiten eingedämmt werden. Ein Abflauen der Brände ist vorerst nicht in Sicht.
Reinforcements are being brought in to fight a 3,600-hectare wildfire in central Florida. The fire has forced the evacuation of some 30 homes around Polk City and closed part of a nearby interstate highway. There have been no reports of any major damage or injuries. The weather going to pose a problem down there, or will the weather help? Well, for that, let's go to Jenny Harrison. Jenny?
Hi there, Ralph. Well, I'm afraid the winds are still quite strong across that whole general area. You can see there not a great deal of cloud, although generally conditions are a little bit cloudy, but I'm afraid perhaps on the negative side, no sign of any real rain in the forecast for the rest of this week. So that perhaps is the one thing really could do with, and also, of course, this time of year it is very warm, certainly down into more southern portions of Florida. Now, there's a system across the northeast, and there's also a major system out to the west, and really it's this system in the west which is producing the most significant weather over the next 24 hours. Now, some very heavy rains along California, particularly into San Francisco, and also gusty winds, and on top of that, some pretty heavy snow as well across into the Sierras. In fact, as much as 12 inches overnight Monday into Tuesday. Now, if I actually run the sequence through Monday into Tuesday, you see that system begin to push further inland, as I say, the snow to the mountains, and then we have this cold front here, which is gradually just dropping down from Canada, and some really cold air behind that system, some snow around the Great Lakes Monday into Tuesday, and really cold air, as I say, coming down from the Arctic into the northern plains. Also, as that system pushes across into Quebec, so we'll see some snow flurries into northern portions of New England, but for much of the southeast and as much of the east as well, things do remain dry.
The crew of the United States Space Shuttle Atlantis is patiently circling the globe. The U.S. Space Agency, NASA, is awaiting weather conditions deemed suitable or at least not unsuitable for landing. High winds at the Kennedy Space Center in Florida have forced NASA to call off 2 landing attempts. There is also bad weather at an alternate landing site in California. But NASA says there's no real hurry. The spacecraft has enough food and fuel to stay in orbit until Wednesday.
Deja vu in orbit as the crew of the U.S. Space Shuttle Atlantis prepares once again to come down to Earth.
Good morning, Atlantis. We've got to stop meeting like this.
Conditions look better for a landing this time around. The U.S. Space Agency NASA was forced to cancel Sunday's scheduled landing as well as Monday's attempts because of bad weather. Atlantis is expected to land at Kennedy Space Center in Florida in about 4 hours.
Now, a few words about Florida here. 2 major stories. Of course, one, the shuttle landing that you just mentioned earlier. That, we're thinking, should have better conditions today. At least that's what NASA's saying right now. So it should be able to land later this afternoon, and that's some good news. The other one is the fire. Still no chance of rain. Most of the rainfall will be across the north and east here, as another area of high pressure builds in across the plains, with more cold air coming down here across the region.
Ooh, good thruster firing.
Oh, yeah. Isn't that amazing? It really is. Oh, no doubt. Like we got about 12 inches to go, so I bet we let the motion.
He's good to the quarter inch.
I can't.
Easiest to bend over if you can get your head in there. You'll just get some comfortable. And you just extend all of your limbs.
Sender. Hi, Femi.
Hello there, Anita. I'm actually watching the weather on the west coast of the US because just on February the 7th, the Atlantis shuttle went up into orbit to install a new space laboratory in the International Space Station. It is waiting now to come out of orbit. Let me show you the landing times, potential landing times now for Edwards Air Force Base. The next one coming up at 20:33 GMT. Let me give you the weather conditions there. Scattered clouds, winds not too bad, 20 kilometers an hour. And this is mission control. Let me take you over to Houston. Houston, we don't seem to have a problem for the next couple of hours. And in the next 14 minutes, the Atlantis shuttle should be going into de-orbit burn. And as we can look at here, this is the Edwards Air Force Base. And you can actually see a little bit of fair weather cumulus. This is stratocumulus. This is the reconnaissance plane at the moment is checking all the cloud cover to make sure it's safe to land, and also checking the wind speeds as well. I'll keep you up to date with that weather situation. Let's head back to the weather map, see how things are shaping up for the rest of US weather. And you can see that cloud just gradually keep creeping in to the western coast of the US, but actually we have some colder air also creeping down. So let's catch up with that weather picture. And behind that, some very cold air, Arctic air, affecting much of the US weather scene. More rain heading into the west coast, hopefully not before the Atlantis shuttle actually comes down. And then as we see into the southeastern coastline of the US, that's when you're most likely to see those warmer temperatures as we head way down towards the south. Atlanta at 17, Miami warm at 26 degrees in Celsius.
Crew transport vehicle at the Edwards Air Force Base facility moving into position.
Atlantis, Houston, no action on your APU-1 message. We're seeing it warm up. Should be fine in a moment.
Thank you.
All three auxiliary power units now running aboard Atlantis, those providing secondary backup to the primary auxiliary power unit providing hydraulic power to the orbiter. Atlantis now in a heads-up position with the nose basically tilted or configured 40 degrees above center with the wings level. This in preparation for beginning the interaction with the Earth's atmosphere 11.5 minutes from now. Atlantis' altitude is 160 statute miles, headed toward the southeastern tip of New Zealand, still traveling orbital velocity at 17,000 miles per hour. Time to touchdown, 42 minutes, 20 seconds. That call a moment ago about auxiliary power unit number 1 simply is the system waiting for its water spray boiler. It's basically water cooling system to kick in to keep that auxiliary power unit's temperature within range. All three are in good shape. Atlantis' nose is pitched up about 40 degrees as it prepares to move into the Earth's atmosphere. All of the reaction control system jets, the roll, pitch, and yaw jets are all active. The movable surfaces on the wings and tail are currently off and do not become active until Atlantis begins moving into the Earth's atmosphere. Two and a half minutes to entry interface. Current altitude is 495,000 feet, or about 93 statute miles. Range to the landing site, 5,600 statute miles. Time to touchdown, 33 minutes, 40 seconds.
Like flames. It's split up. Yellow, very bright yellow orange flame. Oh, I see something.
I see it in the
Can you see it?
recorder, yeah.
There you go. We got the plume. Cool. I also want to show over here. Ain't seen nothing yet. Baby, just. Yeah, when I roll out of the bed on the way to the bathroom, trying to dive for the door and hit the floor, huh?
Atlantis, Houston, take TAC in.
Take TAC in.
Atlantis' onboard tactical air navigation units are now receiving data from the radio beacons that are located at the landing site. Atlantis' speed is down to 4,700 miles per hour at a range of 260 miles from the landing site. Current altitude 140,000 feet. Time to touchdown, 10 minutes.
Atlantis, Houston, on energy approaching the hack. Winds are now 210 at 17, peaking at 24. Breaks down to 16, peak 23 on the head, and 4, peak 6 from the left. Expect to see thin cirrus until the 90. You are nominal drag chute deploy.
We copy the winds and weather and nominal drag chute deploy.
Atlantis is traveling 746 miles per hour, just about to go subsonic at an altitude of 10 miles or 55,000 feet. 32 miles from the landing site. Time to touchdown, 4 minutes, 5 seconds. Commander Ken Cockrell now flying Atlantis as it approaches the heading alignment circle, an imaginary circle around which he flies the orbiter to set up for final approach to landing.
Atlantis, Houston, slightly low at the 180 due to nav.
Atlantis, copy.
Altitude 22,000 feet. Now traveling 500 miles per hour. Time to touchdown, approaching 2 minutes.
Atlantis, Houston, slightly low at the 90.
Roger, on to 90, and we got the airport in sight.
Atlantis, Houston, copy, field in sight.
Pilot point of view camera, this unique view looking out the forward windows of Atlantis as Commander Ken Cockrell sets up for final approach to runway 22. Concrete runway just coming into sight there at the Edwards Air Force Base facility. Altitude 11,500 feet. Time to touchdown 1 minute 20 seconds.
Es sieht gut aus, meine Damen und Herren, in Kalifornien. Die Atlantis ist in Sicht. Dort haben wir das erste Bild. Es scheint jetzt doch alles ganz planmäßig zu verlaufen. Sie durchquert die letzten Wolkenfelder über der Fläche von Kalifornien und wird dann landen in Edwards. Sie sollte ja heute
On
schon
final approach now, 3,400 feet.
1000 Meter, also ist sie noch hoch, 3400 Fuß über dem Landefeld in Kalifornien. Und es sieht alles wunderbar aus, nach den ja doch ein wenig aufregenden letzten beiden Tagen wegen des schlechten Wetters und der dicken Wolkenschicht in Florida musste jetzt nach 2 Tagen der Landeort verlegt werden von Florida nach Kalifornien, nach Edwards, weil man dort besseres Wetter hat. Es ist kein so großes Problem. Wunderbar. Die Erde berührt, der Fallschirm geht auf, die 5-köpfige Crew wird doch glücklich sein, diese kleine Hängepartie überstanden zu haben.
And nose gear touchdown. Atlantis rolling out on runway 22 at the Edwards Air Force Base, completing a 5.3 million mile journey, delivering a science laboratory to the Expedition 1 crew and the International Space Station. STS-98 marks the 47th landing at the California
Und der
site
Kollege
since the shuttle
kommentiert noch einmal die Mission der Atlantis. Sie hatte ja zur Raumfähre ISS Destiny gebracht. Ein großes Weltraumlabor hat sie dort abgelegt, abgegeben, auch Verpflegung gebracht. Verpflegung an Bord hatte sie in einer Menge von 1350 Kilogramm Versorgungsgüter, Wasser, Lebensmittel, Reservecomputer, Kleidung, DVDs. All das hat die Atlantis mitgebracht zur ISS und hat dafür auch Abfall mitgenommen. 380 Kilogramm Abfall hat sie von der ISS runtergebracht. Ja, und es ist wirklich alles gut gegangen. Es ist für die NASA ja auch kein ungewöhnlicher Vorgang mehr. Solche Verzögerungen bei Landungen gab es von Raumfähren nun schon öfter mal. Es gibt für solche Fälle genügend Treibstoff immer mit. Die Crew ist darauf vorbereitet. Sie hat sich sogar gefreut, hatte es gehießen. Gestern noch, weil man auch versucht, Rekorde im Weltraum zu brechen. Derjenige, der mit hier ist an Bord, der Kommandant Kenneth Cockrell, der sagte schon, es macht ja nichts mehr, ein bisschen länger da drin bleiben. Ich habe ja schon den längsten Shuttle-Flug hinter mir. Zusammen mit Thomas Johnson hält er einen Rekord. Er war 1996 18 Tage lang im Weltraum. So, wir sind alle glücklich, alles ist gut gegangen und so können wir fortfahren bei uns im Programm mit NTV Motor. Schauen Sie rein, meine Damen und Herren.
Of the Shuttle Atlantis, having just landed a few minutes ago with 5 astronauts on board, originally landing on Sunday, but that was postponed and the Kennedy Space Center landing was changed over to Edwards Air Force Base. Just a few minutes ago, this was the Shuttle landing.
Main gear touchdown.
Atlantis spent 2 extra days in orbit. The crew returned to Earth having installed the most expensive segment.
And nose gear touchdown. Atlantis rolling out on runway 22 at the Edwards Air Force Base, completing a 5.3 million mile journey. Laboratory
just a few moments ago, that was a landing. The shuttle is now live on the, there's live pictures of it, live on the Edwards Air Force Base runway. There'll be more coming up on that in World News in just a few minutes, and Q&A returns in just a moment.
Yeah, there's the HUD. Great.
Good picture?
Can you see that?
Yep, it's a good picture.
Great.
Until we get land under it, we'll leave it as it is.
Okay, sounds good.
You guys are flying great.
They never did tell us what the weather was.
Mach 2.
Yep. Mach 2. They sure didn't. Be nice to know what clouds to expect, wouldn't it? I just can't understand that.
Well, what does it look like?
Well, it looks like there's an undercast.
It looks pretty cloudy to us back here.
Well,
That's a good picture.
make a nice picture.
That is a great picture.
Like Taco's going to get the logs of instrument time on this one. Okay. I will. You know it. Good. Okay, 1.6 Mach. Going to be a right turn. I see that, a right turn.
So cool.
And I do not see the... Wait a second. It's real hazy. I could make out some of the lake... Atlantis, Houston, on energy approaching the hack. Deploy. Copy, nominal drag chute deploy, and my covers are all open. Same here. Okay, 1.1 Mach. Comes the rock road. Mach 1. CSS. The CSS 0.97. That isn't too bad. Wait, it comes now. Does it now come? Okay. It's not because you're flying, is it? No, it is. Okay, just check it. Okay, 0.95 Mach. I'm getting my flight controller power on. There it is.
Now.
I see it. Very cool. Okay, call the hack. I will call it for you. You're looking great. I see you with centered needles and on energy. Got about a minute to go. Looking great. Needle still centered, looking good. About 40 seconds to go to the hack. Yes, my friend, you are looking good today. 30 seconds. Seconds to go. I'm also waiting for the landing gear ISO, Marcia.
Okay.
Okay, 5 seconds. 4, 3, 2, 1. See you starting a right turn. Go into the needles, they're centered. Looking real nice. There you go, 1.15 Gs. Looking real good, Taco. You keeping the needle centered, that's great. Waiting for the landing gear ISO still, Marcia. Not open yet, but I'm watching it. I'll open it in a little bit if it doesn't open. Okay, it's open.
Atlantis, Houston, slightly low to 180 due to nav.
Atlantis copies. Yeah, I see you pulling up the gun just a little bit, just slightly low. You're doing okay. You're coming to the 90. And I'm showing you about 20K at the 90, so you're looking good. You can bring it up just a little bit if you want. Drop it just a little low. Okay, make sure you're not on HID.
Atlantis, Houston, slightly low to 90.
Roger, on to 90, and we got the airport in sight.
God, that's gorgeous.
Okay.
Atlantis, Houston, copy, field in sight.
Looking good, Taco. There's pre-final. Show you rolling out.
You have MLS.
Okay. We're going to the close. We're at the close aim point. I see 2 white lights. Looking fine. God, this is fun. Yeah, it is. It's awesome. Waiting for the overlay to settle down. Keep the nose low for guidance. Oh, I like it up here. There you go. I know you do. I'm showing mine is right. Mine's right, too. You got to approach and land the body flaps at trail. I would disregard that for lineup. I will. And do visual. 2 and 2, looking good.
The wind has picked up, so we may not have the energy they think.
That's true. Okay, 5,000 feet, checking rad out. 2 is good. 1 is good. You could stay on 1.
I'm on 1, decluttered.
Okay, I am too. There's 4,000 feet. 3,000, speed brakes, 23.
Roger.
Coming up on 2,000 feet, pre-flare next.
And the pre-flare arm to gear, please.
Your gear is armed, you got a light. Looking good on your lineup. You got 1,000, max speed's 317. Going for the ball bar, keep the pull coming. 600, 500, 400. Gotta get the gear, 300. Gear's on the way. Get the ball bar a little bit high, little bit high. 100, 260. Keep it coming down. Ball bar, 50 feet. Looking good. 20, 230, 15, 10, 230. Keep it off, keep it off, keep it off. Touchdown. Shoot is away. 200, 195. Derotate.
Coming down. Back it up.
I will. 170. Big. Okay, looking good. Brake lights are open. And hold off. You're at mid. Behind the brake. Okay, there's 50. 40, you could ease up. 30 knots. 25. 20 knots. 15. 10 knots. What?
Atlantis on a glide slope of about 19 degrees, 6 times that of a commercial airliner. On final approach now, 3,400 feet, setting up for the pre-flare maneuver. And the gear deploy upcoming at an altitude of about 300 feet off the runway. And the landing gear is now down and locked. Main gear touchdown. And nose gear touchdown. Atlantis rolling out on runway 22 at the Edwards Air Force Base, completing a 5.3 million mile journey, delivering a science laboratory to the Expedition 1 crew and the International Space Station. STS-98 marks the 47th landing at the California site since the shuttle program began.
Stop, Houston.
Atlantis, Houston, welcome back to Earth after placing our destiny in space. We'll meet you on page 5-3. We have no post-landing deltas.
Okay, we're going to 5-3, and thanks, Scooter.
And Atlantis is now
We hear you loud and clear on UHF.
We'll stop on the runway, now beginning to press on through the post-landing timeline, essentially safing the orbiter. Commander Ken Cockrell making contact with the convoy commander, and the convoy team now beginning to move into place. The crew will go through a post-landing safing of the orbiter for the next 30 to 45 minutes or so before being in a position to climb out of the orbiter into the crew transport vehicle for routine post-landing medical checks.
Fähre Atlantis ist nach 13-tägiger Mission mit 2 Tagen Verspätung soeben in Kalifornien gelandet. Die geplante Rückkehr zum Weltraumbahnhof Cape Canaveral in Florida war nicht möglich. Starke Winde verhinderten immer wieder ein sicheres Aufsetzen. Die 5-köpfige Besatzung hatte das Forschungslabor Destiny zur internationalen Raumstation ISS gebracht.
Mit 2-tägiger Verspätung landete die US-Raumfähre sicher auf dem Luftwaffenstützpunkt Edwards in Kalifornien. Starke Winde hatten die Landung des Gleiters in Florida verhindert. Während ihrer fast 2-wöchigen Reise hatte die 5-köpfige Besatzung das Forschungslabor Destiny an der internationalen Raumstation ISS installiert.
Every flight has a patch, even the agency has a patch. Here's our flight patch, our cake. We haven't eaten that yet. And we're suiting up in the suit room in the crew quarters at KSC. There's me, of course, and our pilot, Mark Polanski. Doesn't know what it's going to be like, but he knows it's going to be good. Tom Jones, very relaxed. Beamer, I guess he's relaxed. He's not saying much. And finally, Marcia getting all prepared for her trip to orbit.
Just heading out on the Astrovan going to the pad, which you're going to see here in a second. I don't know what you could say about sitting on top of a rocket all loaded up and ready to go. It was pretty exciting. And 6 seconds before launch, the solids light. And, excuse me, yeah, not the solids, I hope. Then the solids light. Yeah, that's why I'm the pilot and he's the commander. Water going down, we clear the tower, and about now I'm starting to wake up. It was just tremendous going uphill. Can't tell you, it's hard to describe the feeling of acceleration as you throttle up, you're rolling, you just feel all of that power as you're heading uphill. This is kind of the view I think the folks saw down there as the moon's coming up over there on the left in the glow, and I don't think that this video probably comes close to doing it justice, and it looks pretty fantastic. See the shock waves coming off the vehicle, and watch the SRBs come off, which makes everybody happy. Eight and a half minutes after we're going to be in orbit, you can kind of see us down here. And then pretty soon we're opening up those payload bay doors and getting the first glimpse out the windows at the laboratory.
Well, we got right to work on stowing all of our equipment. Marcia unstows her hair. And we're ready for the rendezvous.
As we talked about before, we're going to bring our docking port up to touch the docking port on the bottom of the Unity node. And this is a view out we have a camera looking straight up our docking port. And there's me flying the vehicle out the back window, and all of us working to make it happen. A view from service module as we come up, and actually we're doing our tail forward spin around maneuver. And then we're getting closer to Unity, and they're seeing us as closer to them. You can see the lab in the payload bay. We're much closer now, probably about 20 or 30 feet away. The bottom of the docking port's being illuminated by the lights that we have shining up to keep it in view. Here we come down to a couple of feet away. You see the orbiter docking system ring extended on a couple of spring shock absorber looking things, and you'll see why in just a moment. And that's the aiming cross that we use to fly up and keep everything in the center. Actually, there's quite a bit of forgiveness in this. You're allowed about 3 inches and 3 degrees of error as you come together. And then the ring is retracted and brought down so that the two surfaces are touching each other, and then there's some very powerful hooks that emerge from the lower surface and grab a hold of the station and pull the two vehicles together and make a hard mate. And here's the view out the front windows after we're docked. We are all over that station, or it's all over us.
And then we came inside. Here's Shep ringing the bell, welcoming us inside. And we're looking around the node right there. So for those of you that have worked on the node, let's see what we can see in here. Well, mostly us and cables. There's my centerline berthing system camera right there. So the lab will go, attach lab here is what it says on the outside. PMA first, then lab, as those of you who wrote that. So we all got on board, and here's the obligatory photo op. And then we went to work. I had to get the arm out, so there's the arm, there's the lab, and the rest is history at this point, which I'm glad of.
Yeah, part of the fun of getting ready for an EVA is wearing the funky underwear, actually. And actually, this is the underwear that we wear under there. It has liquid cooling lines through it. And then you don't really put the suit on, you get into it, as you can see. And as you can probably see how tight it is in there, but one of the advantages of being in space, once again, is that Roman can go all over the airlock to get us dressed. And that's what he did. And like I said, he did a fantastic job with that. And you can see he actually can get up on top of the ceiling there to put on our helmets.
Okay, we're emerging into the payload bay for the first EVA, and Marsha's got the docking port ready to move. And I guess you can see her moving the docking port, the PMA, off the front of the node, and she's moving it into position.
This is the part of the Z1 truss where the PMA was going to go. Here's Tom out here going mom back, and here's the PMA on the end of the arm. And here's the view from his helmet camera as he gets it ready to be in position. Then I got off of that, came down and grabbed the lab, and Beamer gets out of the way. Smart man. Pulling the lab out of the bay here. It's the hard part is done, and I've picked the rate up. You can see it took about 20 minutes, 15, 20 minutes to flip the lab, and we can't show you that, so we're going to go through it a little bit faster here. They put the lab in 180 degrees out, and I've been doing nothing but trying to explain why, and, you know, pick a reason. I don't know. Here it is at 90 degrees, just about 90 degrees, and the best view was what Tom and Beamer had outside. So here's the lab 90 degrees to the payload bay being shot from up on the truss. Continue to flip it around. It just was amazing, and so the tourists are always taking pictures of everything. almost all the way around, and there it is, all the way around and getting ready to be put onto the node, and it just slid in there as happy as could be. There it is, all attached. Yay is right.
And here's after signing the paperwork, we opened the hatch, and then we took a camera in first to let the people of the space program and of the world take a view of this new piece of space hardware first. And this is the way it looked when we opened the hatch. Very clean, pristine, and as I said, the air was clean and cool, and just looked like a wonderful place to be. Here we are coming in to take a look.
Like I said, first thing that happened, Sergei said, "Watch this," and did his 4-point roll. And the commander, not to be outdone, that poor pilot just can't figure out which way is up there.
And again, we talked about moving the rack around, and when something gets in your way, you just kind of float past it. Lots of cables, cameras, you name it out there as we're moving this thing in place.
Here we are on EVA-2, moving the PMA down to the end of the lab now. This is the view from the centerline berthing system camera. And this is the target that I used. I was looking at my own reflection here in the mirror on the PMA, which was the best cue that we used at all. There's the PMA getting ready to get attached to the lab.
Once the PMA was attached to the front of the lab, I got to work on the arm. Marcia had given me a good place to step into it, and here we are removing the PDGF, the grapple fixture, from the orbiter sidewall, and then I was able to pull that away and then take the ride up to the lab to the installation point. And then Bob met me there, and with our two pistol grip tools, we were able to bolt it into place and install all the wiring that would get it ready for serving as the base of the station robotic arm. So we're finishing up that task right here. Then, as Bob mentioned, we got the window shutter installed. That was his job. And here he is opening the shutter for the first time. And there's a blanket that protects the window during launch. And so the two of us peeled back that coating and looked inside Destiny from outside. What a moment this was for us to look in and, hey, here comes Sergey. And the whole crew was in there, and they were able to come over and say hello. They also asked us to come back in about 20 minutes. It was dark outside, so we just have our floodlights illuminating it. But when the sun came up, Bob came back over for another photo op. That's his gold visor. And in it, you see reflected the window of Destiny. And then they brought over the IMAX camera. So here's Bob locking into place with his body restraint tether. And Sergey was the camera operator for this photo pass. And he says, stand by one. I'll have the camera right back. And there's the 3D IMAX camera. And we've screened some raw footage of this camera. And the view outside into the payload bay just knocks your socks off. Can't wait to see the movie that comes out of this work.
The third spacewalk was my turn to ride the arm. And the primary purpose of this spacewalk was to move a spare radio antenna that was connected to the sidewall of the payload bay. And there we are. I'm on the arm on the upper part of the picture, and down on the lower part with the red stripes is Tom. Tom unhooks it from the payload bay. I grab it, and off we go. And Marsha's taking me for the ride of my life here. As you can see, it was quite dark, but I ended up about 20 feet above the lab and holding this 250-pound monster, and then put it down on the Z1 truss so we could stow it there. And that's a spare, just in case the primary breaks, the station crew can use that one. Our next job, as we talked about with the slides, was to go up the power truss, the P6 truss, and take some pictures of a radiator being deployed. So this is actually a picture of me translating up there, and then we watched them take the radiator out. And they're actually controlling this from inside, and we're just doing photo documentation. And there you see on the left, the radiator deployed. And so then we continued up the power truss, the P6 truss, and started to look down. At this point, we're about 130 feet up from the payload bay, and you can look down the truss, you can see the lab off to the top, and then we, after that, we came back down for some more work on the lab, and that's a picture Tom's taken of me.
Well, we already saw a slide of exercise, so here it is in motion, and I think we talked about how you get a lower body workout, but we haven't talked about how you work out your abs. Then there's the stationary 4-point roll.
Well, we're going to take a tour of the station now as it was when we left it. We're leaving the service module. There's their central posts section with all their control. We're coming into the section that connects the service module to the FGB. This is a hatch right here with a cover on it. This is the FGB, this cargo stowage module right here. Behind all of these panels, our things are stowed. Sometimes they're out in the aisleways here. Right here is where Yuri was sleeping on the wall. There are handrails everywhere. This was actually a pretty clean module. You stowage guys, look at this. It's the way it needs to be. This is the way they move their air back and forth between the different modules here. This is the section that now connects the FGB to the node. Here's the PMA that we're coming through here. This was the hardest turn to make. You get up ahead of steam and you'd smack right into the top of that. They had one of their spacesuits stowed right here. Now we are in the node. This is the lab, which we have seen before, and so we'll just take a turn here and head for the shuttle. Down through this PMA, which was our front door, there is the hatch to that. We're now in our airlock. We are moving air back and forth between the shuttle and the station. Here's the hatch. Here's one of the EVA suits. Another 90-degree turn here through the airlock, and we're in the middeck.
Well, unfortunately, our week docked with International Space Station Alpha came to a close, and we Shep rings the bell, and it's time for the Atlantis crew to leave. And it looks like I'm waiting for Shep to ring the bell. I'm actually waiting to figure out how to do this without hurting myself again. Following me is Roman, and the rest of the crew follow after him. And then finally, when it's time for Marcia to go, and I think this crew was sad to see us go. There was another crew coming up in 3 or 4 weeks, but they don't get a lot of company up there. This is a view of the Russian solar arrays and undocking.
As we back away here, you could see the station looking like it's moving, when in fact we're the ones that are leaving it. Out the window out the back, you can go ahead and see part of the PMA as we slowly back away. For the rendezvous guys that are here, it was a tremendous honor to get to do this, and it flew fantastically. It was really great. Up here you could see what was a laser, that we had a handheld laser to go ahead and get distance and range. You could see the laboratory that is now in place, and you could see the window, and that was the window shutter that's behind there, and those guys were looking out at us as we backed away, and that's where we used to be docked. A great view taken from the station as we fire some of our RCS reaction control system jets, maintaining attitude as we back away. You really can feel those things as they pulse. We slowly backed away to 450 feet. And here are some views. As you can see, we talked about those gold arrays up on top of P6 as we slowly maneuvered, and a half a lap around the station taking a look at our handiwork. And it was really quite the thrill to get to do that. Although every once in a while I had to ask for some help because everybody was blocking my view through the window taking pictures. Great shot as we came over South America and the Andes here. And you could see the shadow of the shuttle on top of the station as we said our farewells.
Time to come home, close the payload bay doors. Did this 3 times on this mission. And payload bay is empty, time to get dressed in the orange suits. Here's Marcia taking her turn. This is like being born again, and although it's probably a little bit worse. And Bob and I were the valets helping her get dressed. We did a good job there. There's the plume coming out the back as we enter the atmosphere. And gravity begins to return to the shuttle and the crew, and there's Marcia with her checklist as the flight engineer.
Coming on home in the final turn, we're coming down at about 20 degrees, 6 times steeper than an airliner, 6 to 7 times at about 300 knots. We're at Edwards. There's not a lot of water down here. Well, it used to be. I guess it's a dry lake bed, and there's runway 22 as we're rolling out on final.
We dive down on final till we get to about 2,000 feet above the ground, and then we're aiming at a point short of the runway. When we get to 2,000 feet, we start a gentle pull-up. Here's a little anticipation cues telling us it's time to pull up. And we pull up and get on an inner glide slope that's about 1.5 degrees, a very shallow glide slope that you can control very well. At about 300 feet above the ground, Roman lowers the landing gear. You don't like to put it down too early because of all the drag it causes, and you don't want to put it down too late because of the drag it would cause on the runway. And we float down the runway about 2,000 feet and make a couple of landings here. And then Roman puts out the drag chute, which gives a nice little tug, makes you know that it's out there. And then at 185 knots, we lower the nose to the runway. And you'll see that the nose gear touchdown is a little more firm than the main gear. You can see the airspeed or the ground speed now on the upper left. And we slow down at about 60 to 70 knots. We cut the chute away so that it doesn't damage the engine bells. This is, after all, a reusable spacecraft. It had flown 20-something missions when we flew it, and it's got many more in it. And you should all be very proud of the hardware and the training and the operations that go into our space flights. We do a really great job here at NASA.
And after he lands, he will make a turn on the runway to taxi back to the ramp and the main demate device, which is at the south end of the shuttle landing facility. He had a slight crosswind since he landed with the left wing down and landed on the left gear with touchdown on the right gear following to keep the crosswind from getting in under the left wing and blowing it off the center line. On the back of Atlantis is the ferry flight tail cone, which protects the three main engines of the orbiter, as well as providing some aerodynamic efficiencies as it flies along. It will now taxi back to just short of the turnoff to the ramp.
Zurück in der Zivilisation auf der US-Forschungsstation McMurdo. Anne Bancroft und Liv Arneson geben erste Autogramme. Die Eiseskälte steckt ihnen noch in den Handgelenken. Monatelang waren die beiden auf Skiern unterwegs, kämpften gegen die Eiseskälte. Erst waren wir natürlich frustriert. Eigentlich wollten wir doch auf Skiern hier ankommen, aber jetzt ist es trotzdem schön, da zu sein. Aufzugeben, das ist schon hart für mich, verstehen Sie. Wir haben die Expedition jahrelang geplant, waren so viele Tage unterwegs und plötzlich ist alles vorbei. Vor 3 Monaten, November 2000. Ein Flugzeug setzt die beiden Frauen im ewigen Eis ab. Jetzt sind sie auf sich allein gestellt. Ihre Schlitten wiegen über 100 Kilo. In der Antarktis beginnt der Sommer. Es sind aber immer noch minus 34 Grad. Gleitschirme ziehen die beiden, wenn der eisige Wind aus der richtigen Richtung bläst. Die Frauen kommen gut voran. Im Januar erreichen sie den Südpol. Sie sind angekommen. Freude bei den Betreuern in der Funkstation. Anne Bancroft und Liv Arneson müssen weiter, laufen gegen die Uhr. Sie wollen am Ziel sein, bevor das Meer zufriert. Dann wären sie die ersten Frauen, die die Antarktis bezwingen. Vor 4 Jahren schaffte das ein einzelner Mann. Der Norweger Børge Aulsland durchquerte das Eis, allerdings auf einer anderen, kürzeren Route. Aulsland erreichte das Ziel mit letzter Kraft. Auch die beiden Frauen kämpfen gegen Schneestürme und Eiseskälte. Doch am Ende siegt die Zeit. 700 Kilometer vor der Forschungsstation müssen sie aufgeben, haben das Ziel nicht rechtzeitig erreicht. McMurdo, die Station. 2 Urkunden für Liv und Anne. Immerhin haben sie zumindest das Festland der Antarktis durchquert, über 2700 Kilometer. Erst der anbrechende Winter konnte die beiden Powerfrauen stoppen.
Thick smoke shut down a 16-kilometer stretch of a key interstate. Authorities say it could remain closed through the weekend. Firefighters say the flames could burn for days if there is no rain. And that quite cleverly brings us to Femi Oke, who tells us what the chances are for rain there. Femi?
Well, Ralph, the fire could burn for days. In fact, the fire probably will burn for days. This is our radar summary picture. If it's green, it's rain. If it's blue, it's a mixture of, well, if it's blue, it's snow, I'm sorry. And if it's pink, it's a mixture of rain, ice, snow, icy precipitation. So here we have the rain heading across the southeast, which is good news. This whole area is very drought-stricken, and this central part of Florida has extreme drought, the worst drought since the Florida records began. And that rain gradually easing up, just sweeping the northern section of Florida, and then moving up through into the Carolinas. And here is where that rain is needed, and here is where the rain is in fact. So this is really not good news for those firefighters. They really could do with a lot more help than they're getting from the weather right now.
This is what scientists say the sun sounds like. The equivalent of a solar heartbeat. Solar scientists used listening devices to unravel some of the mysteries of Earth's nearest star. It's not the actual sound. Sound can't travel through the vacuum of space, but a recreation based on the waves recorded by the devices. Each pitch corresponds with the movement and vibrations of various hot gases as they flow like rivers beneath the sun's surface, similar to how trade winds blow on Earth. Scientists translate the sounds they make into images. This allows a unique glimpse inside the sun's complex architecture to answer questions about its temperature, chemical makeup, and how gases inside ebb and flow.
What we're finding is that there are very interesting structures inside. There's an equatorial belt of faster moving material, and then farther up near the poles, we believe that there's a jet stream of material moving about 60 miles an hour up at a very north latitude.
The Michelson Doppler imager aboard a sun-orbiting satellite captures movements on the surface, seen here. Each of these granules, by the way, is the size of Texas. To hear the sounds, scientists had to speed up the vibrations 42,000 times and compress 40 days of solar activity into just a few seconds. As for what we can do with this information, NASA scientists hope that listening to the sun will give us earlier warnings of dangerous solar activity, the kind that can disrupt power lines, satellites, and navigational systems here on Earth.
Right now, we can image when an eruption happens on the surface of the sun and determine when the disturbance is propagating across the solar system. But by imaging the far side of the sun with sound waves, we can determine what's over the horizon.
Ann Kellen, CNN, Washington.
Mudslides in Peru and drought in rainforests from Asia to Brazil. The culprit, El Nino, and NASA scientists say some version of El Nino may be coming back.
For next summer, this model is saying that, you've got a good shot at a moderate warming trend in the Pacific Ocean that is just under El Nino, and saying we got to keep a very close eye on it.
The model he's talking about, NASA's latest forecasting tool, a virtual climate. It starts with worldwide satellite observations and other information on Earth's oceans, land masses, and atmosphere, fed into an elaborate supercomputer program. NASA is hoping its virtual climate will help forecasters make better predictions and issue earlier, more accurate warnings so people can be better prepared for whatever the weather may bring.
Head back here to the weather studio and let me show you what an international panel of governments actually decided. In the next 100 years or so, the temperature of the Earth could go up. It seems very likely 5 degrees in Celsius, causing really big problems for developing countries which are already suffering from drought, and also very small island nations as well, which may see their water levels go up. We will certainly keep you up to date with that weather situation. Meanwhile, get you up to date with current weather. That's more climatology.
Dying, a giant rock from space, and how it changed the course of history. Scientists is calling the mother of all extinctions. They've long known that an asteroid wiped out the dinosaurs 65 million years ago. Well, now they say there was an even more devastating event that wiped out 90% of life on Earth. Ann Kellen has more on the so-called Great Dying and if it could happen again.
Scientists say 250 million years ago, before even the dinosaurs existed, an asteroid 4 to 8 miles across slammed into Earth with a force of 1 million or more earthquakes. That impact caused volcano eruptions that buried much of the Earth in lava and kicked up so much dust and ash it blocked the sun's rays, making the Earth dark and cold, destroying most of its life.
This is
probably the most famous type of animal that existed in the Paleozoic. It's called a trilobite. And the trilobites went completely extinct.
As did most of the 15,000 species on Earth at the time, including shellfish and coral. Fish fared better than most.
These very active animals actually made it through with only about 40% rather than 90% extinction.
No one knows where this asteroid hit, but others have left their mark, like the smaller one in Arizona. Does this mean it could happen again? If so, when? You shouldn't worry, say scientists. They calculate an asteroid hits Earth once every million years. We know where the big ones are, and even if a smaller one was coming at us, we'd get plenty of notice.
We would almost certainly have decades, if not centuries, to go before that impact would happen. So we'd have a long time to think about what to do about it.
Scientists made this discovery by digging deep into the Earth's core. They found gases only found in outer space, trapped in carbon molecules called Buckminster fullerenes, or buckyballs. Scientists now say those alien gases rode in on a speeding asteroid. Even though the devastating impact destroyed life, it paved the way for the dinosaur era 25 million years later. Ann Kellen, CNN, Atlanta.
That's American Edition. I'm Ralph Wenge. The news continues.
Der Versuch, einen riesigen Forschungsballon um die Erde zu schicken, ist nach nur wenigen Stunden gescheitert. Nach dem Start in der Nähe der australischen Stadt Alice Springs trat in der dünnen Kunststoffhaut des Ballons ein Leck auf. Das Gefährt wurde per Fernsteuerung zur Erde zurückgebracht. An Bord hat der Ballon Messgeräte zur Erforschung kosmischer Strahlung. Er sollte in 35 Kilometern Höhe fliegen.
Ein Heliumballon, der um die Erde fliegen sollte, ist nach nur 6 Stunden in der Luft wieder auf den Boden getrudelt. In der dünnen Kunststoffhaut war ein Leck entstanden. Der Riesenballon erreicht einen Durchmesser von 128 Metern und eine Flughöhe von 35 Kilometern. Er soll als billige Alternative zu Forschungssatelliten eingesetzt werden.
Die US-Raumfahrtbehörde hat bei der Erforschung von Alternativen zum Einsatz von Satelliten einen Rückschlag erlitten. Der in Zentralaustralien gestartete Heliumballon war nur wenige Stunden nach seinem Start wieder auf die Erde gefallen. Er hatte wissenschaftliche Messgeräte an Bord und sollte sie bis zum Rand der Erdatmosphäre tragen.
Wildfire in central Florida. Still, heavy smoke is keeping a 10-mile stretch of Interstate 4 closed. The highway links Tampa and Orlando. The fire burned about 10,000 acres and authorities hope to reopen the highway on Tuesday.
Es war eine Reise von 3.800 Kilometern, nicht im Auto, nicht im Zug, sondern auf Skiern, quer durch die Antarktis. 2 norwegische Abenteurer nahmen die Tiefkühlstrapazen auf sich und machten sich auf den Weg zu einem neuen Rekord. Erstmals wurde die Antarktis in dieser Länge von einem Menschen ohne fremde Hilfe durchquert.
Sie ist unendlich weit, unwirtlich, eisig und kalt. Die Antarktis, schon immer eine der größten Herausforderungen für Abenteurer. Und steht der Wind gut, dann erleichtert ein Gleitschirm den beschwerlichen Weg durch die Eiswüste. Mit 170 Kilogramm Gepäck im Schlepptau durchquerten die Norweger Eirik Sonnerland und Rolt Bay die Antarktis. 3 Monate lang ohne Unterstützung von außen. Wir hatten nicht viel dabei. Brennstoff für 120 Tage, Lebensmittel für 95 Tage, Schlafsäcke und ein Zelt. Das war's, nur das Nötigste. Es war ein großer Traum und wir haben ihn uns erfüllt. So lange haben wir darüber nachgedacht und es so lange geplant. Doch dann konnte es losgehen. Ende Oktober begann die Expedition an der norwegischen Antarktisstation. 2000 Kilometer später erreichten sie kurz vor Weihnachten den Südpol. Danach folgten weitere 1800 Kilometer zur legendären Scott-Station. Für die Norweger eine Ankunft mit Happy End.
Weather. Most people just wanted to know, why would anyone want to jump out of a perfectly good plane? CNN forecaster Kevin Corriveau, Guillermo Arduino and me, Femi Oke, took off in a plane this week and then jumped out of it. The weather was perfect for hurtling through the sky at almost 200 kilometers an hour, mostly clear with a nice view and just some high wispy cirrus cloud above us. The plane reached 4 kilometers and then securely attached to an instructor, fingers crossed, we rolled out of the door. When you fall at this altitude, the wind whips past you. It's difficult to take a breath. And all the time you're trying to remember to keep your feet at a 45-degree angle, stretch out your arms and arch your back, your ears are popping at the same time. The higher up you travel, the cooler the weather becomes. But I don't think any of us really noticed. We were a little preoccupied at the time. After a minute of free falling, you open the parachute, and then you can admire the scenery at a more leisurely pace. Finally, 5 minutes after you jumped out of a perfectly good plane, you're right back on terra firma.
Thank you so much.
Okay, good job. Love to. I was shaking all the way.
You want to do it again?
It's great.
Having all made it back to Earth in one piece, would we dare to go skydiving again? Of course. We've already booked a date, weather permitting.
So, was I scared? Of course I was scared. It's the most terrifying thing in my life. Can I reenact it? Well, probably. Ah! That's it from World Weather. World News continues after this next break. Do stay with us.
Pluto ist ein offener Streit unter Wissenschaftlern ausgebrochen. Der sonnenfernste der bekannten Planeten sei in Wirklichkeit ein übergroßer Asteroid oder Komet, behauptet der amerikanische Astronom Neil deGrasse Tyson. Ausschlaggebend dafür sei die Beschaffenheit des Pluto. Er hat einen Fels- und Eiskern mit einer Oberfläche aus Eis und Methan, wie die anderen Asteroiden. Pluto war 1930 entdeckt worden.
The U.S. plans to build a national missile defense system with a new administration in Washington to deal with. Moscow's been quick to show the world that although it may longer be a superpower, it's a power to be reckoned with. Jill Doherty reports.
3 days before the NATO chief arrives in Moscow, Russian war games. A yearly event, but a potent message that Russia, in spite of its weakened military, can still fight battles on land, sea, and air. A highlight of those military exercises, a test launch of 2 Topol-M intercontinental ballistic missiles. Russia's most modern and sophisticated ICBM, hard to detect and even harder to intercept. Moscow is warning the United States that if Washington goes ahead with a national missile defense system, Moscow will equip the Topol with multiple warheads. Russian President Vladimir Putin has mounted a diplomatic lobbying campaign against the missile defense system. But there was nothing diplomatic in recent comments by U.S. Defense Secretary Donald Rumsfeld that Russia is an active proliferator of sensitive military technology to the very countries that threaten the U.S. According to one key member of the Russian parliament, friction and even potential conflict with Russia could be the result of a harder U.S. policy.
It will play hardball and will not hesitate to apply very strong pressure on Russia if Russians do something which Americans do not like, for instance, selling weapons to Iran or supporting China in some other areas, or continuing their cooperation with India.
Russia is shipping nuclear fuel to India, and the U.S. wants it stopped. Washington says that will be an important item on the U.S.-Russian agenda of the Bush administration. All this tough talk is a rude awakening for Moscow.
Even 1 month ago, there was a strong illusion within the Kremlin that it would be much easier to deal with a Republican president, but not with a Democratic president.
But Russia is prepared to fight fire with fire. It may no longer be a superpower, but it seems to want to act like one. Jill Doherty, CNN, Moscow.
Das umstrittene Programm mit dem Namen National Missile Defense, kurz NMD, ist eine schwierige Technologie. Wird irgendwo auf der Erde eine Rakete gestartet, erkennen Spionagesatelliten der USA Startpunkt und Flugziel der Rakete innerhalb von Sekunden. Rund 30 militärische Satelliten sind dafür im Einsatz. Hunderte von Radaranlagen und Sensoren am Boden ergänzen das US-Beobachtungsnetz. Während die feindliche Rakete auf die USA zurast, werden die Daten aller Beobachtungsposten ausgewertet. Ein Supercomputer errechnet aus Lage und Geschwindigkeit der Rakete ihre Flugbahn und kalkuliert die Gegenmaßnahmen innerhalb einer Minute. Der Gegenschlag beginnt. Eine Abwehrrakete startet aus einem versteckten Silo in Alaska. Die USA wollen hier 100 Raketen stationieren. Die Abwehrrakete wird von Satelliten, dem GPS-System und Radar auf das feindliche Ziel gelenkt. Kurz vor dem Rendezvous setzt es eine kleine Mini-Rakete aus, die auf das feindliche Geschoss zufliegt, es selbstständig erfasst und sich blitzschnell in seine Flugbahn manövrieren kann. Über dem Ozean, in etwa 200 Kilometern Höhe, trifft die Mini-Rakete das feindliche Geschoss und löst den Atomschlag aus, bevor es den amerikanischen Kontinent erreicht. In den USA hat man bereits mit dem Bau der Raketenabwehr begonnen, obwohl der ABM-Vertrag dies strikt verbietet. Kritiker fürchten, dass China und Russland weiter aufrüsten werden, um das Gleichgewicht der Abschreckung aufrechtzuerhalten. Ob NND technisch je funktionieren wird, ist allerdings umstritten. Zu schnell sind die Geschwindigkeiten, wenn zwei Raketen aufeinander zufliegen. Das sogenannte Kill Vehicle, also Tötungsfahrzeug, muss sein Ziel zentimetergenau treffen. Es kann sich mit seinen Steuerdüsen autonom bewegen und opfert sich schließlich beim Zusammenstoß über dem Ozean.
Umbilical is disconnected. 0. +1, +2, +3, +4, +5, +6, +7.
Das Kill Vehicle wurde erfolgreich getestet und bereits in Versuchsraketen installiert. Zahlreiche Fragen bleiben jedoch ungelöst, etwa wie das Kill Vehicle den Sprengkopf von den Attrappen unterscheiden will, die jede Angriffsrakete zur Täuschung auswerfen kann. Neben der Raketentechnologie ist NMD auch ein Programm der USA zur elektronischen Aufrüstung. 32 neue Infrarotsatelliten werden ins All geschossen. Zusammen mit einem digitalen Radar sollen sie jede Flugbewegung auf der Erde erfassen, melden und auswerten. Im Oktober 1999 wurde die Raketenabwehr erstmals komplett getestet.
211, on command voice, western range launch is go, range clear to launch.
Colon 43.7.8.
Liftoff, stand by for promotion time.
Standing by. GBIRS, we see it on the sky.
Die US Air Force startete in Kalifornien eine Langstreckenrakete und steuerte sie auf die Marshallinseln zu. Im Pazifik löste dies den NMD-Alarm aus.
5, 4, 3, 2, 1, mark.
Computer starteten die Abwehrrakete und lenkten sie mit Hilfe von Radar und Satelliten auf die Langstreckenrakete zu. Von Osten der Angriff, von Westen der Gegenschuss. Ganz wie in der Doktrin der Vergangenheit. Die Computerauswertung zeigt die letzten Sekunden im Leben des Kill Vehicle.
5, 4, 3, 2, 1, mark.
2 von 5 Tests waren bis heute erfolgreich. Weniger umstritten und viel weiterentwickelt ist der Laser als Zukunftswaffe. In Albuquerque, New Mexico, arbeitet die US-Luftwaffe an einem gigantischen Laserprogramm. Laser entsteht durch das optische Pumpen von Licht. Das erzeugt Photonen der gleichen Wellenlänge, die schließlich als Licht mit hoher Energie entweichen. Das Laserlicht ist scharf gebündelt und verliert seine Energie auch nicht auf große Distanz. Nur, Laserlicht war bislang zu schwach, um ernsthaften Schaden anzurichten. Das hat sich gründlich geändert. Dieser Hochenergielaser brennt alles nieder, was sich ihm in den Weg stellt. Je stärker, desto besser, ist die Philosophie in den USA. Die US Air Force setzt sie bereits in die Praxis um.
Der luftgestützte Laser ist derzeit eines der wichtigsten Waffenprogramme der USA. Er ist Teil der neuen Militärstrategie und wird die Art und Weise, wie wir in Zukunft Krieg führen werden, völlig verändern. Unsere Fähigkeit, mit Lichtgeschwindigkeit auf 400 Kilometer Entfernung eine feindliche Mittelstreckenrakete abzuschießen, ist ein riesiger Fortschritt für die Welt.
An aggressive theater ballistic missile is a tremendous leap forward in capabilities for the world.
Der luftgestützte Laser ist in einem militärischen Jumbojet eingebaut und kann mehrere startende Raketen hintereinander aus der Luft vernichten. Bis 2009 soll eine Flotte von 7 Flugzeugen weltweit einsatzbereit sein.
Ein Vorteil ist, dass wir über alliiertem oder neutralem Gebiet operieren und über 400 Kilometer weit schießen können. Der andere Vorteil ist, dass wir eine Rakete schon kurz nach dem Start treffen. Was sie auch immer an Bord hat, ob chemische, biologische oder atomare Fracht, die Rakete fällt mit ihren Sprengköpfen auf das Land zurück, das sie abgefeuert hat.
Die erste Boeing 747 wird gerade ausgeweitet und zum Laser-Jumbo umgebaut. Vorne sind der Kommandostand und die Lasermodulation. Lasergeneratoren und Chemietanks füllen die Economy Class. Die Flugzeugnase wird durch eine vollbewegliche 7-Tonnen-Linse ersetzt, die den Laserstrahl blitzschnell auf das bewegliche Ziel lenken kann. Weitere Laser vermessen Lage und Bewegung der Zielrakete sowie Dichte und Brechung der Atmosphäre.
Der Messstrahl, der die bewegliche Linse an der Flugzeugnase leitet, gibt seine Messwerte an den Lasergenerator weiter, der im hinteren Teil der Maschine sitzt. Der Hochenergiestrahl geht dann durch diese Leitung wieder zurück, wird entsprechend gewandelt und schließlich über diese bewegliche Linse auf die Rakete abgefeuert. Die Rakete explodiert und fällt auf die Erde zurück.
40 Sekunden nach dem Start durchbricht die Rakete die oberste Wolkenschicht, wird vom Messstrahl des Flugzeugs erfasst und fixiert. Innerhalb von 10 Sekunden muss der Laser-Jumbo feuern, sonst ist die Auftriebsphase der Rakete vorüber. Der Megawatt-Laser schweißt ein Loch in den Raketentank und die Rakete explodiert. Versuche an einer Raketenhülle aus Titan zeigen die enorme Kraft des Lasers, die er auch auf große Entfernung nicht einbüßt. 1,3 Milliarden $ kostet das Programm. Der erste Schuss ist für 2003 vorgesehen. Die schneeweißen Sanddünen von White Sands im US-Bundesstaat New Mexico. Hier entwickeln die USA gemeinsam mit Israel ein mobiles Raketenabwehrsystem. In der Missile Range steht die modernste Laserkanone der Welt. Israel lässt sich diese exklusive Technologie 200 Millionen $ kosten. In 5 Jahren soll sie im Heiligen Land stationiert werden und feindliche Kurzstreckenraketen, etwa Katyuschas, abwehren. Erste Tests verliefen positiv.
Okay, we got a target, 06.
2 Testraketen werden kurz hintereinander verschossen. Der Infrarotlaser sucht sich sein Ziel, feuert mit hoher Energie und kann ohne Nachladen blitzschnell mehrere Raketen nacheinander anpeilen und abschießen.
Okay, he's down, I'm skipping. Firing on a second one.
Sie sind eine Republik, diese Vereinigten Staaten von Amerika, und die Kuppel des Kapitols kündet, auch wenn die jüngste Wahl noch schwer im Magen liegt, vom Stolz auf die Segnungen der Demokratie. Man muss sich das in Erinnerung rufen, wenn der Präsident kommt, Hof zu halten vor den Vertretern des Volkes. Alle sind da. Die Führer des Heeres und die Hüter des Rechts. Abgesandte fremder Staaten sowie die Großwesire und Minister des Reiches. Hochherrschaftlich hält der Präsident Einzug bei den Abgeordneten beider Häuser des Parlaments.
Mr. Speaker, the President of the United States.
Weil dieser Präsident neu ist und dieser Auftritt eine Premiere, wirkt er etwas nervös am Anfang, doch das ist schnell vorbei. Wir legen einen gesteigerten Haushalt vor. Wir haben Prioritäten gesetzt. Wir werden Schulden tilgen. Wir haben für Notfälle vorgesorgt. Und dennoch bleibt Geld übrig. Also will Bush die Steuern senken. 1.600 Milliarden Dollar in 10 Jahren. Löblich, aber zu viel, findet die Opposition. Und ohne die geht gar nichts, weil die Wähler dem Parlament ein Patt beschert haben. Bushs Pläne, sagt einer der Oppositionsführer, verlassen sich auf Prognosen, die so zuverlässig sind wie ein 10-Jahres-Wetterbericht. Niemand kann hell sehen. Der Präsident wirbt mit allen Mitteln. Eine leibhaftige Vorzeige-Durchschnittsfamilie hat er mitgebracht, Stephen und Josefina Ramos. Sie würden $2.000 im Jahr sparen und könnten das gut gebrauchen. Dass 40% des Steuersegens dem 1% der Superreichen im Lande zugute kämen, das bleibt unerwähnt. Noch eine Riege stummer Zeugen ist begeistert von Bushs Plänen. Die USA sollen sicherer werden. Um unser Volk, unsere Freunde und Verbündete zu schützen, müssen wir eine Raketenabwehr installieren. Da ist George Bush Beifall von beiden Seiten des Hauses sicher. Wie überhaupt sein Auftritt eines vor allem deutlich macht: Trotz knappestmöglichem Wahlausgang, ohne Wenn und Aber ist er der Präsident und weiß es zu schätzen. Der Herr hat gesprochen, das Hohe Haus war ein Palast. Jetzt wird es sich wieder zum Basar verwandeln.
Die friedliche Abendstimmung am Puget Sound vor Seattle lässt an alles Mögliche denken, nur nicht an Katastrophen. In der Stadt sieht es weniger romantisch aus. Die Nacht nach dem Erdbeben wird von Aufräumungsarbeiten bestimmt. Vor allem die Strom-, Gas- und Wasserleitungen müssen überprüft und repariert werden. Doch der Schrecken wird den Menschen noch lange bleiben. Wie den Leuten in diesem Restaurant in Downtown Seattle, denen beim Mittagessen das Geschirr um die Ohren flog und Regale mit Flaschen von den Wänden entgegenkamen. Die Überwachungskameras haben die Sekunden während des Bebens festgehalten. Eine 60-jährige Frau erlitt einen Herzinfarkt und starb. 160 Menschen wurden verletzt. Nach einer ersten Bilanz belaufen sich die Zerstörungen in Seattle auf 2 Milliarden Mark. Neben einigen Brücken und Straßen sind es vor allem die älteren, zum Teil noch aus dem 19. Jahrhundert stammenden Backsteingebäude, die beschädigt wurden. Insgesamt sind die Schäden für ein Beben der Stärke 6,8 jedoch relativ gering. Verhängnisvolle Erdbeben haben in San Francisco und Los Angeles in den letzten 12 Jahren weit mehr Zerstörungen angerichtet. Die amerikanische Pazifikküste gilt als besonders gefährliche Region. Deshalb versucht man sich auch heute besser auf solche Katastrophen vorzubereiten, werden Brücken und Gebäude besonders verstärkt bzw. flexibel konstruiert, dass sie bei schweren Erdstößen nicht brechen, reißen oder einstürzen, sondern in sich beweglich sind, sich verwinden und so die Schläge aus dem Untergrund abfedern können. Präsident Bush hat der Erdbebenregion schnelle Hilfe zugesagt. Allerdings streicht er gerade für sein Steuersenkungsprogramm 50 Millionen Mark von der Erdbebenvorsorge. Aber das nächste Erdbeben an der Westküste kommt bestimmt. Die roten Punkte auf der Karte zeigen ihre Häufigkeit hier. Sie entstehen durch die Bewegung tektonischer Erdschichten, die sich langsam übereinander schieben und dabei Druck im Erdinnern erzeugen, der sich in Beben entladen kann. So wie die Pazifikplatte und die amerikanische Kontinentalplatte an der Küste von Seattle. Glücklicherweise lag das Epizentrum diesmal aber 55 Kilometer tief in der Erde. Deshalb war der Schaden trotz der Stärke der Erdstöße so gering. Die Erdbeben kommen, ohne sich groß anzukündigen, sagt der Geologe James Devine. Wir haben bis heute noch keine Methode zur Vorhersage oder Warnung entwickeln können, die zuverlässig wäre. Seattle ist diesmal verglichen mit anderen schweren Beben mit dem Schrecken davongekommen, so wie die 30 Menschen, die während der Boden unter der Stadt tanzte, ausgerechnet im 185 Meter hohen Wahrzeichen Seattles, dem Space Needle, eingeschlossen waren. Erst nach endlos langen 2 Stunden wurden sie befreit.
Wir haben oft über schwere Erdbeben berichtet in den letzten Wochen. Indien, El Salvador, jetzt Seattle Und es gab auch viele kleinere Beben, zum Beispiel am Dienstag in Griechenland, letzten Sonntag in Frankreich. Ist unser Planet im Moment ungewöhnlich unruhig? Das fragen sich auch die Menschen an der amerikanischen Westküste. Besonders in Kalifornien haben sie seit langem Angst vor dem großen Beben, the big one. Waren die schweren Erdstöße gestern die Vorboten? Antworten darauf geben die Wissenschaftler vom Geoforschungszentrum in Potsdam. Jan Meyer ist dorthin gefahren und hat mit den Experten gesprochen.
Das Geoforschungszentrum Potsdam. Nirgendwo sonst in Deutschland werden Erdbeben so genau analysiert. Auch die Erschütterung von Seattle. Aus Potsdamer Sicht war es ein starkes, aber für die Gegend typisches Beben. Mit weiteren Beben, die zur Katastrophe führen könnten, rechnet man nicht. Das Institut registriert langfristig gleichbleibende Zahlen von Erdbeben. Aber die Meldungen über Katastrophen häufen sich.
Die Zahl der Erdbebenkatastrophen nimmt zu, aber nicht die Zahl der extremen Erdbebenereignisse. Es sind die Menschen, die einfach verletzbarer werden, die durch Bevölkerungswachstum immer mehr Regionen besiedeln, die man eigentlich nicht besiedeln dürfte, die durch Zunahme der Armut sich weniger schützen als vorher. Die Anzahl der Erdbeben, der starken Erdbeben bleibt die gleiche, aber die Katastrophenanzahl, die nimmt zu.
Irgendwo bebt es fast ständig unter der Erdoberfläche. Auch Deutschland ist bedroht. Im Zeitraffer des Computerbildes wirken die Erdbeben der vergangenen Wochen wie ein Blitzlichtgewitter.
Auch Deutschland ist gefährdet, nicht in dem Maße wie etwa die Region um Seattle herum. Wir müssen hier in Deutschland mit Beben doch bis zur Magnitude 6 oder sogar leicht darüber rechnen. Das sind Beben, die durchaus erheblichen Schaden anrichten können, sodass wir uns wirklich vorbereiten müssen. Die Regionen hier in Deutschland, die betroffen sind, sind einmal die Niederrheinische Bucht, also um Köln, Aachen herum, dann der Oberrheintalgraben, Stuttgart, Karlsruhe, Basel, dann die Schwäbische Alb und das Vogtland südlich von Leipzig.
Expeditionen führen in alle Welt. Satelliten übertragen Messdaten auch schwächster Vibrationen. Und doch bleibt die Hauptaufgabe unerfüllt. Vorhersehbar sind Erdbeben immer noch nicht.
Ja, leider sind Beben nicht vorhersagbar, bisher jedenfalls nicht. Und nicht im Sinne der Angabe des Ortes, der Stärke und ganz besonders nicht der Zeit. Was man heutzutage ganz gut kann, ist so eine Wahrscheinlichkeitsangabe zu machen. Also zu sagen, mit einer bestimmten Wahrscheinlichkeit tritt ein Beben einer größeren Stärke innerhalb eines längeren Zeitraums, das sind meist Jahrzehnte auf.
Fast überall auf der Welt sollte man sich auf Erdbeben einrichten. Die Wahrscheinlichkeit für Deutschland wird immerhin mit 10% prognostiziert.
Beautiful, bright weather. As a special present to Sonia and all the Washington team, it's the last chance I have to work with you, Sonia, and I do the weirdest, wildest weather stories, and you always say, thank you, Femi. I have to say, thank you, Sonia. We miss you from the World Weather Centre.
Oh, Femi, thanks. We'll be right back after a short break.
Sonia, I do want to embarrass you for just a moment for the benefit of our viewers, as you would have heard from Femi. After more than 7 years with CNN, 7 stellar years, it is Sonia's last day at the anchor desk. Now, years of speaking with celebrities, newsmakers and heads of state. Just this week, you might remember a terrific interview with the Colombian President, Andres Pastrana, as you can see there. Sonia, I first met you here in Atlanta on my first day at CNN nearly 5 years ago, and after 20 years of reporting, you made a virgin anchor feel right at home, helping me to adjust to something I had never done before. It was typical of you, selfless and all class. Over the last few years, we've done the same thing in at least one regard. We both had 2 children, dual passport holders, all of them. And I know you're going to be spending time with yours in the days and months and maybe years ahead. I hope you're not going to be lost to broadcasting for too long, however. You are simply too good, Sonia. Not for the first time and hopefully not for the last. It's back to you in Washington, Sonia. We're going to miss you.
Oh, Michael, thank you so much. You're a good friend, and I certainly always enjoy watching you anchoring, especially that wonderful work in Sydney for the millennium. None of us will ever forget that. Well, for me, even though I felt like I'd left 6 weeks ago, this really is goodbye, and it's been good to have 6 weeks to say goodbye to everyone, but it's been more than 7 years, more than 5,000 programs, I've counted them, bringing you the news on CNN. But this is not about me. Television news is never about one person. It is all teamwork, and it is that team that I would like to thank. All the people who've made it possible to report the news from Washington. It is the capital of the superpower. We've reported decisions, the White House, Congress, the Pentagon, decisions that have had an impact all over the world. So to all our colleagues all over the world, and most of all to my colleagues and friends here in Washington, thank you. So for the last time, I'm Sonia Rousselet in Washington.